Okay, in this video we're going to look at vector calculus, so going from displacement to velocity to acceleration and vice versa using our differentiation and integration, but this time we're going to be doing it in 2 dimensions. So if x is a function of t and y is a function of t, then you could write your displacement is equal to xi, so a function of t times I plus a function of t times j. And your v then, to get to your v, you differentiate your s with respect to t. So likewise, you have to differentiate your t with respect x with respect to t, sorry, your y with respect to t to get down to x dash y dash, and then x dash y dash, or else x dot y dot, and then differentiate again to get to x double dash or x double dot, and y double dash or y double dot. Okay, so it says in this example, a particle moves such that at time t seconds, its velocity v is given by v is equal to 3t t squared minus 4. Find the speed of the particle when t is equal to 3. So the first thing you've got to do here is find the velocity, so when t is equal to 3. So when t is equal to 3, our v, first of all, will be equal to 9, and then it'll be 3 squared minus 4, which is going to be 5. So that means your speed, and remember, speed is equal to your modulus of your velocity, or your magnitude of your velocity, whatever way you want to say it. And then, so that means your speed is going to be equal to the square root of 9 squared plus the 5 squared. And if you do that out, you're going to get the square root of 106. And when I do that out on my calculator, see what I get 10.3 meters per second, and that's to 1 dp. Now part B says, find the values at which the particle is traveling parallel to I. So just say if parallel to y, or parallel to I should say, parallel to I, then just say the y part, I should have said y component, is 0. So we're just going to put that means we're just going to put t squared minus 4 equal to 0, which means t squared is equal to 4, which means t is equal to plus or minus 2. Let's think about this. Find the values of time. We'll just leave it as that. So strictly we shouldn't really have a negative time, but we'll just leave it as that for the purpose of this answer. Part C says find the acceleration when t is equal to 5. So you can see here I've just written down my v, because my A is going to be, how I'm going to get it is differentiate your V with respect to T. So we'll just leave it as a column vector, make life easy. That's just going to differentiate the 3T, you'll just get 3. Differentiate the T squared minus 4, you'll just get 2T. So that's your acceleration. And so the acceleration when T is equal to 5, so just say when T equals 5, your A is going to be equal to, and it's just going to be 3. And then it's going to be 2 times 5, so it's going to be 10, and that's going to be meters per second squared. Okay, part D, last part of this question says that find the displacement of the particle at t is equal to 4, given it is initially at the origin. So to get to your displacement vector, what you've got to do is integrate this time your velocity. So if you integrate your velocity, you're just going to get, as a column vector, you're going to get 3t squared over 2. And then you're going to get t cubed over 3, and then minus 4t, and then plus c, where c, very importantly, will be a column vector. Now we're going to look at how we can do this. So we know what we're told. We were told initially, so that's when t is equal to 0, your s is equal to the 0 is equal to 0, so that is the 0 vector. So we can use that to find out what your c is. So just say when t is equal to 0, s is equal to 0, 0. So that means 0, 0 is equal to, and put in 0 into 3t squared over 2, you're going to get 0. Put 0 into t cubed minus 3 minus 4t, you'll get 0, plus your c. C, I should have said, was a vector, so your c is also equal to 0. So therefore your c just works out to be your 0 vector, so you don't need to write it in. So what we know then your s is equal to 3t squared over 2, and then that's going to be t cubed over 3 minus 4t as a column vector. That's how we get our displacement. And what we needed to find, I've forgotten, what we needed to find was our displacement when t is equal to 4. So a wee word just to make things quite clear, just say when t is equal to 4, your displacement is going to be equal to 3 times, that's going to be 4 squared divided by 2. That's in your first row of your column, and then it's going to be 4 cubed divided by 3 minus 4 times the 4, and I'll just work out what they are, which is 24 in the top line and 5 1/3 in the bottom line, and that's going to be meters. Let me see, it was the displacement, thankfully. If it had said the distance, we would then have had to have done the modules of this, but this is our displacement vector, so 24 and 5 1/3 meters is our answer for this part. This next example, it says find the speed of p when t is equal to 2. So in this question, you start off, you have got your displacement, so we can get our velocity first of all by differentiating your displacement with respect to t. So still keep it as a column vector, it makes life very simple. That's just going to be 3t squared, and that's going to be 2t on the bottom line. So just say when t is equal to 2, your velocity first of all is going to be equal to, bear with me a second, your velocity is going to be equal to 3 times 2 squared, which is going to be 12, and then 2 times the 2, which is going to be 4. So that's your velocity. Your speed is then going to be equal to the square root of the 12 squared plus the 4 squared, and if you work it out, that's whatever that's going to be. The square root, let's just give it straight to an answer, square root of 12 squared plus 4 squared. Press equals, and on your calculator that comes out nicely as 4 root 10. It's a perfect answer, meters per second, but just press your SD button. They may want that as a decimal, so it's 12.7 meters per second, and that was to 1 dp. Okay, part B says find the time for which the coordinate of s is, the y coordinate, sorry, of s is minimum, and the displacement of p at this time. So for part B, bit of a strange question. They're looking for you to just look at the y part of your displacement. So the y part of the displacement was t squared minus t. So if you see the words like minimum, maximum, turning point, anything like that, you're really thinking about differentiating. So we're going to do dy by dt. So you're going to get 2t minus 1, and then what you're going to do is put whatever you've just found equal to 0. So 0 equal to 2t minus 1, which means 1 is equal to 2t, which means t is equal to, and t is equal to 1/2. Okay, we just need, just to be guaranteed to get your full marks, just need to check. So d2y by dt squared, and if you do that you get 2, which is greater than 0, which implies it is a minimum. Okay, and then the question I said find the displacement at this time of a minimum y value. So just say when t is equal to 1/2, your s is equal to, so we're just putting our value of 1/2 back into this equation up here. There's going to be 1/2 cubed minus 4, and then 1/2 squared minus 1/2. So we're just going to put that in and see what we get. So 1/2 cubed minus 4, and then 1/2 squared minus 1/2. Put that in and see what we get. So we have got minus 3 7/8, and then minus 1/4. Okay, part C, I've sort of filled it in for us, most of it. It says find the average velocity of p from t is equal to 1 to t is equal to 3. So I'm just going to scroll up a bit so I can see this all. So you can see what I've done here. Average velocity is equal to displacement divided by time. So I'm going to say I'm going to need to find the displacement when t is equal to 1 and find the displacement when t is equal to 3. So when t is equal to 1, you're going to have 1 cubed minus 4, which is minus 3. So sorry, that's going to be 1 cubed minus 4, which is minus 3. 1 squared minus 1 is going to be 0. When t is equal to 3, you're going to have 3 cubed, which is 27, minus 4, which is 23, and 3 squared, which is 9, minus 3, which is 6. So your change in displacement is the 23, 6, minus 3, 0. So 23 minus 3 is 26, and 6 minus 0 is just 6. So your average velocity then is that displacement vector divided by your time. So from 1 second to 3 seconds is 2 seconds. So if you divide 26.6 by 2, you'll have 13.3 meters per second. Okay, in this example it says if v is equal to t squared I plus 3tj, and first part it says find a when t is equal to 2. So to get your a, you're just going to do your dv by dt. So in this case, differentiate your v, you're going to get 2ti plus 3j, and just say when t is equal to 2, your a is equal to 2 times 2, which is going to be 4i, plus 3j, and that's going to be meters per second squared. For part B, it says to find s when t is equal to 6. Now it's in this one, your s is just equal to 18i minus 24j, and that is when t is equal to 0. So that's going to come into play in this one. So to get your s as well, and when I say the s, I mean the function of s in terms of t, you're going to integrate your v with respect to t. So you've got your v, and if you integrate it, what you're going to get for your s is going to be t cubed over 3i plus, and that's going to be 3t squared over 2j plus some vector constant c, because it could have I parts and it could have j parts. We don't know. It's not necessarily going to just be a 6 or whatever. We need to find that out. But we know that when t is equal to 0, s is equal to 18i minus 24j. Therefore, 18i minus 24j is just equal to your vector c. So that means your s, the story so far, your s is equal to, and it's going to be t cubed over 3. I'm just going to put all the I parts together, plus 18. That's the I parts. Then plus, and then my j part was going to be 3t squared over 2, and then minus 24. That's my j part. Now the very last bit of this, just say when t is equal to 6, your s is equal to, and you're just firing s in, or firing 6 in instead of the t. So you have 6 cubed, which is 216 over 3, plus 18, that's the I part, plus you're going to have 3 times 36, and that's over 2, minus 24, that's your j part. Run out of space here to write my j in here. Squeeze it in just about. So you work that out and see what you get. And when I worked that out, 216 divided by 3 plus 18 worked out nicely as 90i, and the 3 times 36 all over 2, then minus the 24 worked out nicely as 30j, and that's going to be meters. So when t is equal to 6, s is equal to 90i plus 30j meters. Okay, just another couple of examples to go. It says find a force acting on a mass of 2 kilograms with a position vector r is equal to t cubed I plus 2t squared j at a time t. Okay, so to do this, you've got to remember your force, vector force, is equal to mass times your vector acceleration. We effectively have got your s, but they've called it r. We've got the displacement is equal to t cubed I plus 2t squared j. So what I'm going to do first of all, I'm going to get my velocity by differentiating my r with respect to t. So I'm going to get 3t squared I plus 4t, and that's going to be j, and that's going to be meters per second. Now to get my acceleration, I'm going to differentiate my v with respect to t. So if I do that, what I'll get is 6t I plus 4j, and that's going to be meters per second squared. So you've got your acceleration. What you then want to get is your force. So force, remember, we've said is your mass times your acceleration. So your force in this particular case, my mass was 2 times my acceleration, which was 6t times I plus just 4j. And if you multiply it out, you're going to get your force is equal to 12t I plus 8j, and that's going to be newtons. Okay, last example says if the velocity of a body at time t is given by v is equal to 3t squared I minus 2tj, find expressions for the acceleration a and displacement s of the body at the time t, given that when t is equal to 1, s is equal to 3I minus j. To do the first bit to find acceleration, we don't need to worry about the condition, this condition here. Don't need to worry about it at all, because your acceleration is just your dv by dt. So if you differentiate your velocity here with respect to t, you will get 6t times I minus 2 times j, and that's going to be meters per second squared. To get your displacement, a wee bit trickier. Displacement is, you get your displacement by integrating your v with respect to time. So if you integrate your v with respect to time, what you'll get is t cubed I, and then minus, and that's going to be t squared j, and then plus your constant c. And it's a vector constant here, because it could well have I parts and j parts, we don't know. So we have to look back at this condition. So just say when t is equal to 1, s is equal to 3I minus j. So let's just put that in. So that's 3I minus j is equal to, so putting 1 into this, what you're going to get is just I minus j plus your vector c. A wee bit of rearranging, you'll have 2I, and then, just 2I is equal to your vector c. Therefore, your very last thing, your displacement of the body at time t is just given by t cubed plus 2, I put that in a bracket, that's all my I components, and then minus t squared times j, and that is it done.